In math, there are a lot of things that we take for granted because you know them in a usable sense. Okay, you use these things, but you've never named them. Okay, what all of these gray boxes are is verbal definitions of things that you already know. All right, I'll be brief, but I do need to go through them, and you will need them for the remainder of your math career, and that includes geometry. Okay, so these verbal words that you're learning today or that you're getting exposed to are things you're going to need. Okay, the first thing I want to explain is the closure property, and I'm going to give you examples that go along with it. So first they say, and I know you have this copied, but I'm going to add to it. Anytime you add numbers together, the answer is a specific thing, right? Remember in grammar school when you had to do your fact tests? 2 plus 2 is 4. She'd mark it wrong if you put 5. Why? Because the answer is a unique real number. Okay? The answer is a unique real number. In other words, there can be a wrong answer. Okay? So like if I said 3 plus 2, the result is 5. And it's always 5. Okay? Or 3 minus 2. The result is 1. They don't have that in there, but you can kind of think of that as case closed. Okay? I always think of this as case closed. There is no other answer to these questions. Same thing goes for multiplication. They say, well, the product of any two numbers is always going to be a unique real number. And that's because the answer is always whatever the answer is. There's never a time when 6 times 2 is not 12. Never. Okay? It's always going to be 12. Okay? That's what the closure property shows us with respect to addition and with respect to multiplication. I did give a subtraction sample, but commuting. Commutative means to move. You guys had this in the blue book last year. My 7th and 8th graders are crying about it right now. But the commutative property means to move. And what that states is you can reorder addition and multiplication as you see fit in order to make your brain answer the question more easily. Okay, in this world of electronics, you're thinking, but I stick everything in a calculator. That's true, but if you didn't have a calculator, you can use your knowledge of how math works to move stuff around. For example, A plus B plus C is the same thing as A plus, well, I'll move this, C plus B. Okay? In other words, 1 plus 2 plus 3 is going to be the same result as 1 plus 3 plus 2, right? I was able to reorder that, and it still is the same answer. Okay? They gave a 2-piece answer, but I think it shows better with a 3-piece sample. So this is addition. In multiplication, the product of A and B and C is the same as the product of B and A and C. Again, your book gives 2-piece answers, A, B answers. I like showing it with 3. I feel like it clarifies a little more. So 1 times 3 times 4 is the same thing as 3 times 1 times 4. Not rocket science. That's what the commutative property allows us to do. Now, the reason these properties can get frustrating is because later you're going to be asked why I'm allowed to do this. That's when you're going to need to answer commutative. Or why is this always 12? Because of the closure property. You're going to be asked why certain things are explainable. And these properties allow you to do that. We also know about something called the associative property. and that is to group. In other words, group things together. And this applies to addition and multiplication as well. And the point of this, again, like I said a minute ago about the calculators, the point of this is to group so that you're able to conveniently solve a problem. So the first one, I'm going to say, I'm going to do, trying to think of a good one. 8 plus 3 plus 7. Okay, most of you have no problem telling me that the answer is 18 because the order of operations, the order of operations says to do 8 plus 3, which is 11, and then add 7. Most of you know that, okay? That's what the order of operations tells us to do. But in math, it's oftentimes easier to find tens in things, which means I see a 10 right here. So I just grouped the 3 and the 7, found that 10, and then made 18. This finding the 10 is a nice way to use associative, okay? Or finding something that you know, like say 12 and 8. If it was 12 plus 5 plus 8, if you're anything like me, you're going to go 17, 18, 19, 20, 21, 22, 23, 24, 25. I'm sorry, I have mathematical tools on my fingers. Yes, I do. But I could not only commute the 12, but I could also group these two items and come up with a 25 much more quickly. So in this case, I commuted and then I associated. Okay. I'm always nervous that I'm going to accidentally leave the O off of my abbreviation there. I'm just being honest. Associating and multiplication. Associating and multiplication. So if I have A, B, C, and according to the order of operations, you would do that first. That's what the rule says. But you can do this because multiplication is still the same even if you do it that way. And that can come in handy for stuff like three times, I'm going to just separate them, 6 times 5. You would do 3 times 6 first based on this and then multiply it by 5, right? This is the order of operations. But you do, or you can, regroup and do the 6 times the 5 first. And I think most of you could tell me that 30 times 3 is 90 faster than you could tell me the same thing about this. It's just how your mind works. Okay, same answer, but you can choose to group it this way so that you can answer it more quickly. Everybody has different things that they've memorized more easily. For me, that's just something that I do a lot. And you're already doing it. I know you are. I've seen y'all do it. The last property that you should have copied, and I'm skipping an example, but I want to do this, is the property of equality, properties of equality. So you guys have already copied these, but here's some explanations. Things are equal if they are a mirror image of one another. And I shouldn't say mirror image, because mirror images are technically the opposite, but this property is the reflexive property. Okay, in other words, the same equals the same, identical. Or I can say these two things equal one another, therefore these two things equal one another. Okay, I simply took what it was and flipped it. That is symmetric, which you might think sounds reflexive, E-T-R-I-C. Okay, Just like when you look in the mirror, if you put your hand up, it looks like the guy facing you, the you, has their right hand up. We match symmetrically with our reflection. And you can also say something equals something, which also equals this other thing. Therefore, I can say that this thing equals the original thing we were talking about. And that is called transitive. And the way I try to remember that one is that I can transfer this to this because of these two things that I've been told. Okay? That's transitive. Now, just a couple of examples that I'm going to do with you today to help you, and then you're going to get right into the homework. Mike asked if it's easy, hard. I don't know. Kind of depends on you and how your mind works. Honestly, this stuff was extremely difficult for me because I thought it was rather pointless to name things in math that I'm already doing. That's just how my mind used to work. Yep. And I was very stubborn about it at your age. God rest my teacher's soul. She tried, but I was stubborn. What I'm going to do with you is I'm going to show you a couple of examples, and then I'm going to do a couple orals, and then we're going to get going, okay? So example 1, and this is mine. You have the book for your own time. My example 1 says, I don't like that one. I want a different one. All right, here it is. They say simplify. I don't doubt that you can all tell me by the order of operations that this is 31 plus 7 is 38. But if you do some maneuvering, like, and I'm going to make it a little bit longer than it needs to be. Like if I do 8 plus 23 plus 7, by the way, I just commuted. Commutative property of addition allows me to do that. But I still have to follow the order of operations. 23 plus 8 plus 7. No, pain in the rump. I am going to decide to group these two things. That group is the associative property of addition. Allows me to choose to add these two items up first and come up with an answer of 38. Okay? Some of you might have just gone 38. You're commuting and associating without even touching a pencil. Okay? Here's another one, and this one involves multiplication. Now, yes, you're all very familiar with calculators, but you know how I said in addition, find your zeros? In multiplication, you want to find your zeros too. So I am going to maneuver my 50 over to here. Okay, and I can do that because the commutative property says I can. And I'm not going to do 81 times 50 because I can't do that in my head. But I am going to associate those two items together because of the associative property, which gives me 100 times 81. And I could do that in my head. Okay? Anytime you can do something in your head, I guarantee you it's faster than a calculator. Anytime. Now, it works with algebraic or variables as well. It works with variables as well. And example 2, I'm going to use that one real quick. Example 2. So if I say to you, combine 4 with 5y with 3. Again, these are not in your book. Most of you remember that these items are numbers. That is a variable. By the way, numbers in algebra are called constants. And anything with a variable is a variable. even if it's got a number in front of it. This just happens to be 5y, which literally means y plus y plus y plus y plus y, 5 of them. But rather than get bound up in that, do you guys agree with me that the answer is 5y plus 7? The 4 and the 3 can get combined. The 7 cannot be combined with the 5y because they are not the same item. They are different. Okay? 5y plus 4 plus 3. I grouped 5y plus 7. Multiplication, same idea. This one's kind of funny, actually. I mean, I don't know. I guess it's really not. But 3b, 4c. All right. This literally means take all the numbers and multiply them together. 5 times 3, which is 15, times 4, which is 60. And then take the letters and multiply them together. A times B times C. All right? But a simpler way to do it would be to maneuver the numbers so that they're all together. And I'm going to even put them in an order that I like. And put the letters all together. So I end up with 20 times 3, which is 60. A, B, C. Okay? Most of you, again, are not going to do this much writing, but you needed to be able to see it so that you understood why we did what we did. Okay? All right, here's the few items I have left to show you. Guys, look at page 47. Page 47, the top of the page, number 13. Page 47, top of the page. Name that property. Yeah, this is the stuff that is going to make you nuts if you don't understand your properties. Ask yourself, what did you do? I moved it. What is moving? Commutative. Yes, good. That's 13. 14. Looks like I didn't move anything. But I might have done associating. Very good. I would say 15 is commutative as well. How about 16, Justice? What do you think 16 is? Associative. Correct. The order did not change, but I did choose to group them together, and you would have done that anyway after it's all said and done. Okay, 19. If 7m is 35, then 35 is 7m. If thens are generally equalities. Morgan. Yeah. Nope. If thens are generally properties of equality. It's either reflexive, symmetric, or transitive. If thens. Nope. If thens are generally properties of equality. Reflexive, symmetric, or transitive. Symmetric? Symmetric? Yeah. Symmetric. Every real number is equal to itself. In other words, 2 equals 2. What is that? B equals B. Ben. Reflexive. Okay. 23 is transitive. Okay. It's transitive. They took one thing, explained another thing, and then combined the two. If something and something else is true, then this is true. 25. The order didn't change, but something else did. 25. This is the last one. Associative. Yep, if the order doesn't change, but how we parentheses the items does, that's associating. Very good.